The journey of Venus through the sky is a fascinating dance that has captivated astronomers for centuries. As Earth's neighboring planet, it provides a remarkable example of how the dynamics of celestial bodies operate within our solar system. The phases of Venus, similar to those of the Moon, occur as a result of its orbit around the Sun, and observing them has helped shape our understanding of planetary motion and the heliocentric model of the solar system. Venus follows an elliptical orbit around the Sun, which means it is constantly changing its position relative to both the Earth and the Sun. This orbit takes approximately 225 Earth days to complete, and Venus's proximity to the Sun, coupled with its rotation, gives rise to its phases. These phases are not visible to the naked eye from Earth in the same way that the phases of the Moon are, yet through telescopes, the changes in the appearance of Venus are both distinct and fascinating. The phases of Venus are governed by the interplay between its position in its orbit and its relative position to Earth, resulting in varying amounts of the planet's surface being illuminated by the Sun at different times. When Venus is closest to Earth, it appears as a crescent. This phase occurs when Venus is positioned between the Earth and the Sun, known as inferior conjunction. During this time, only a small portion of Venus's night side is visible from Earth. As Venus moves further away from Earth in its orbit, it begins to show more of its illuminated side, gradually transitioning to a half phase, where half of the planet's disk appears bright. The progression of these phases mirrors the pattern seen with the Moon as it orbits the Earth, though the relative sizes and distances are quite different. The half phase of Venus is an awe-inspiring sight, as the planet presents a clear division between its bright, sunlit hemisphere and the darker, shadowed side. As Venus moves into its greatest elongation, the farthest point from the Sun in its orbit from Earth's perspective, it begins to reveal a more complete, but still partial, view of its illuminated surface. At this point, Venus appears as a gibbous planet, where more than half of its disk is illuminated. The gibbous phase happens when Venus is in the middle of its orbit and transitioning between the half phase and the full phase-like appearance. This is when Venus is most visible in the evening or morning sky, depending on whether it is in the eastern or western sky at sunset or sunrise. It is during this phase that Venus shines most brightly and can often be mistaken for a star due to its intensity and visibility. The final phase of Venus, which can be seen just before it disappears behind the Sun at superior conjunction, is a full disk. However, due to the extreme brightness of the Sun, the full phase of Venus is not visible in the same way the Moon's full phase is. The transition from gibbous to full phase occurs when Venus is on the opposite side of the Sun from Earth, making it almost entirely obscured by the Sun's glare. While a full Venus is theoretically possible, it is rarely observable with the naked eye. Telescopic views of Venus during superior conjunction show a tiny, nearly fully illuminated disk that appears faint and difficult to distinguish due to the Sun's overwhelming brightness. The phases of Venus were a key observation that helped establish the heliocentric model of the solar system. In the early 17th century, Galileo Galilei was one of the first to observe Venus through a telescope, noting its varying phases. This discovery provided compelling evidence that Venus, like the Earth, revolves around the Sun, challenging the geocentric model that suggested all celestial bodies orbited the Earth. The fact that Venus exhibited phases similar to the Moon's could only be explained if the planet orbited the Sun, not the Earth. This observation was pivotal in shaping our modern understanding of the solar system and the dynamics of planetary motion. In the modern era, the study of Venus's phases has continued to contribute to our understanding of planetary atmospheres and orbital mechanics. While we can no longer directly observe Venus's phases with the naked eye, advancements in telescopic technology, including space-based observatories, have allowed us to explore its surface and atmosphere in greater detail. These studies continue to reveal important insights about Venus's extreme environment, which includes a thick atmosphere of carbon dioxide and surface temperatures hot enough to melt lead. Despite the inhospitable conditions on Venus, the study of its phases provides a window into the complexities of planetary science and the ever-evolving journey of discovery in our solar system. Through the phases of Venus, we are reminded not only of the intricacies of planetary motion but also of the history of astronomical discovery that has shaped our view of the universe. From Galileo's first telescope observations to modern space missions, the phases of Venus continue to play an essential role in our understanding of the cosmos. As we continue to observe this celestial body, we gain a deeper appreciation for the dynamic processes that govern our solar system, and for the profound connections between the planets that orbit the Sun.